Okay, welcome to our notes. Today's CLO, or content language objective, is students will be able to create, in writing, equivalent representations of exponentials using graphs, tables, situations, and equations, and the following language: if-then statements, exponential, graph, table, situation, and equation. So based on the CLO, what do you think you're going to do in this lesson? So basically, if I start with the vocabulary, we're working with exponential functions. And it's a new type of function where instead of growing at a steady, consistent rate like a linear did, because remember, linears made straight lines when we graphed them, like this, but an exponential is where x is in the exponent, and then it makes it curve up because it does not grow steadily. It grows slowly at first and then very, very quickly because it's the multiplicative growth, where you're multiplying by the same number each time to get the next number, so it shoots up really fast. And so our goal is to take these type of functions, these exponentials, and then we're going to create equivalent representations. Well, remember, representations in math are graphs, tables, situations, and equations. So if I look at starting these notes, let's zoom in. In math, we have four main representations, ways we represent math. And the goal is to be able to go between any one of them. Like if I start with a graph, I should be able to go straight to a table, straight to a situation, or straight to an equation really fast. Same thing if I started over here at equation. They expect you to be able to go to any one of the other three really fast. And I taught you how to do this for linear equations in Unit 2. So now I'm going to teach you how to do it for exponential equations. A lot of it's the exact same. For example, if you have an equation and you want to go to a table. So this one would be from an equation to a table. So we're going that way. So remember, tables usually on top is the x and then on bottom is the y. And you get to just pick some x's. I like starting with negative, maybe do one that's a 0, a 1, and a 2. You could pick whatever you want your x's to be. But then to get your y, your answer, you have to put these x's into this equation. So I'm going to take the equation and put it in my calculator. So it was y equals 6, parentheses 2, to the power of x. But then let's say instead of x, I put in negative 1. Well, then it tells me my answer, y equals 3. So then if I go back to my notes, in that case, y was 3. If I plug in 0 to that x, I get out the answer 6. Plug 1 into the x, I get out 12. And then if I plug 2 into x, I get out 24. That's how you go equation to table. Then to do the reverse, if I have a table first, and then I want to go backwards and make the equation. To go from a table to the equation, you're going to always want to find first where x is 0. Because the first in an equation for exponentials, it's always something like y equals a, parentheses b, to the power of x. And to show you here, this a is your starting amount, meaning when x is 0, the answer, the amount you have after no time has passed, is how much you start with. And that's 6, and that's what went here in the first spot. So in this one, when you find where x is 0, what is the y? 10, so our starting amount's 10. Then to figure out the b, the multiplier, you can take any number you want. I'm going to start with 10. 10 times something, whatever that b is going to be 15. Whatever that b is. So to figure out what that b is, if I start with 15 and then divide it by the 10, I'd find out that that b was 1.5. So in my equation, b is 1.5. And so that's my equation. As long as the x is up there and the exponent like it should be, this is the equation of this table. So the next two are about table to graph or graph to table. So we're going to be doing this connection, table to graph / graph to table. So if it's a table and I need to graph it, I'm really just plotting my points. Here, let me zoom out so I can see it. I'm really just plotting my points. So remember, the x-axis goes left and right. The y-axis goes up and down. So -1 from my middle means left 1. And the y for this table is a positive 6.6. So I'm going to go left 1, then up 1, 2, 3, 4, 5, 6. And then 0.6 is a little more than half. So I'm going to try to put a dot right there. All right. And then at 0, it's at 10. So here's 7, 8, 9, 10. But it's on the y-axis because it hasn't moved left or right. And then if I try to do 1 and 15, it's going to go up really high. 2, or 10, 11, 12, 13, 14, 15. And it's going to be hard to do the next one. So I'm just going to remember that this curves because it's exponential. So it should curve down and then curve up and make the exponential shape. And it's a rough graph, but this would be a graph. Now, if I want to take this graph and write the table, then I'm just going to pick a couple points to write in here. A good point is always when x is 0, the starting amount. When x is 0 on this graph, if I go up, that y is there at 1. So I just listed this point right here, this y-intercept on this line. I could go backwards to -1 and guesstimate that. I could go forward to +1, and I know right there that's at +2. So I'm going to do that one. At 1, it was at 2. And then maybe at 2, I see it's clearly at 4. So then I'm going to use that one too. At 2, it was at 4. All right. So that's just taking a graph and plotting some points and putting them into a table. You could have picked any of the points. I could have picked this one right here, even though it's all decimals, and I would have had to guess. Could have picked this one up here. You're just picking some points on the graph and writing down those points in a table. Right, next is between equations and graphs. So if I go back up to my main thing, we've done the back and forth between tables and equations. We've done the back and forth between tables and graphs. Now we're going to do the back and forth between graphs and equations. This one here. All right. So if I have an equation, I need to graph it. The quickest way is, remember, if I plugged in 0 here, then my answer is just this 6, meaning I always start at 1, 2, 3, 4, 5, 6, because that's the number in front. That's the A. Then I know the next one's going to be times by 2, and 6 times 2 is 12. So then after one time, I need to be up at 12. So after one time, here's 6, 7, 8, 9, 10, 11, 12. So then I'd put my second point, and then 2 points are enough as long as you remember to curve it because it's exponential. And then I'd have my graph. To get the equation, if they give you the graph first, again, the starting point is where it crosses the y-axis. So the 6, the A, is where it crosses y. So where does it cross this y-axis? At 1. And then to figure out the multiplier, I'm going to just take the next point. So if this one's at 1, the one right after it is up here at 2. And so when it was at 0, my y was 1. When x was 1, my y was 2. So what times 1 becomes 2? Times 2. You could have also done 2 divided by 1 to figure out that we are multiplying by 2. But nonetheless, Choose my multiplier. And so that's graph to equation. Next is between either table to situation or situation to table. So then that would be this guy right here, between table and situation, the back and forth. So, all right. So in all of these, there's two things we are continuously caring about. The first thing is the starting amount. And then the next thing is the multiplier. So you have to figure out both of these before we can create a situation. Well, the starting amount is when x is what? When x is 0, and so the y is going to be 10. So in this situation, we're starting with 10. And then the multiplier, to go from 10 to 15, I can always do 15 divided by 10 to figure out it's 1.5. So then I just have to create a situation where I start with 10, and then each time I'm multiplying by 1.5 or 1.5. So I could pick anything. I start with 10 fish in a pond. So the problem with this one is I can't have half a fish. So let's do algae. You know, like that little mossy stuff at the bottom of a pond. It's like a plant. So start with 10 algae in a pond. I'm going to go with day, it multiplies by 1.5. And that's it. That's all I got to say to go from a table to a situation. If I start with a situation, I need to find my starting amount. So it says I have 200 pieces of paper, so that's what I'm starting with. That's my starting amount. And then I need to find my multiplier. Every day I throw half is my multiplier, of them away. So starting is always at times 0. So I'm starting with 200. Then after one day, half of them are getting thrown away. So it's half of 200. 100. After 2 days, then there's only half of that left. And half of 100 is 50. And then after 3 days, only half of that. And half of 50 is 25. So then this would be the table based off of that situation. All right, now it's between equation and situation, these two. So if I scroll back up, I'm going between equation and situation now, this back and forth. Boop, boop. All right, so again, for my situation, I'm going to always say, what's my starting amount? What's my multiplier? So in my equation, my starting amount's which one? It's the 6. And then my multiplier is 2. And another way to say multiplying by 2, remember, is doubling. So I can say I start with 6 friends. Every school year, the amount of friends I have doubles. I could have also said multiplies by 2, but I went with doubles. So yeah. For my situation, 2 equation. Remember, equations for exponentials are y equals a parentheses b to the power of x. And a is our starting amount. And so in this situation, we're starting with how many? 200, because I just have 200 pieces of paper. And b is my multiplier, and what am I multiplying by? I'm multiplying by half, because I'm throwing half away. And if I'm getting rid of half, then I still have half of it left. So then that's what I'm multiplying by. And so that would be my answer for the equation. And then my final little connection is a graph to a situation. So we're going to do that one real fast. So with all of them, it's the first thing is what is my multiplier and what is my starting amount. For this graph here, my starting amount's what? Starting at 1 because it's crossing the y-intercept at 1. Then if my next one's at 2 for y, so if this is 2 and then this is 1, what am I multiplying by to get from 1 to 2? I'm multiplying by 2. Or remember, you can always do this 2 divided by the one before it to figure out that we were multiplying by 2. So now I just have to create a situation where I start with 1, and then each time I multiply by 2 are double. So I can say, I have 1 pimple every day they will double. That sucks, but that's my situation. All right. Then finally, if they give you a situation like 200 pieces of paper, then each day I throw half away. To start with 200, there's no way my tick marks on y can go by 1, my y-axis. So let's see. What if I go by 20s? So if this first tick mark counts for 20, this one's 40, this one's 60, this one's 80, this one's 100, this one's 120, 140, 160, 180, and then this one would be 200. So at 0, I just start with 200 pieces of paper. So you put your first dot right there. Then after 1 day, it cut in half, and half of 200 is 100. And I could keep going. It's say after 2 days, that cuts in half to 50 if I wanted. Or I could remember this is an exponential that's going down. So it starts up here, and then it curves down. Curve. So you could have put more points to be exactly more precise if you wanted to, but as long as you have 2 and make it curve the right way, you're fine. And that's all of them. That is how you convert between all the forms of an exponential.